right, 9.5 part 2. So we are going to be converting polar points to rectangular points, or rectangular coordinates, and rectangular coordinates to polar coordinates. We're going back and forth. So we have formulas for each. So if we are going from polar to rectangular, we use these two formulas. So we have x equals r times cosine of theta, and y equals r times sine of theta. Think back to when we did unit circle stuff, way back. Remember, cosine always dealt with the x, so cosine goes with the x. Sine, we always dealt with the y, so sine goes with the y. We also have different formulas if we're going from rectangular to polar. So these two formulas we would use. Tangent of theta equals y over x. So this is the same thing that we did before. Tangent is y over x. And then the other one, similar to our Pythagorean theorem, r squared equals x squared plus y squared. So in the first few questions, we're converting our polar coordinate to rectangular coordinates. So the formula that we're going to use here is x is equal to r times cosine of theta, and y is equal to r times sine of theta, bless you. And if we remember from yesterday, in our polar coordinate, the first numbers are r, second numbers are theta. So here we have x is equal to 2 times the cosine of pi. So first thing we want to do is figure out what the cosine of pi is. So I'm going to go to my unit circle, find pi, and we have this point at pi. Cosine tells us we look at the x or the y? The x. So what's our x at pi? -1. Perfect. So we have x is equal to 2 times -1. So x is equal to -2. Then to find our y, we have y is equal to r times sine of theta. So y is equal to 2 times sine of pi. So we go to pi again. Sine tells us we look at the x or the y? The y. So our y is 0 here. So y is equal to 2 times 0. What's 2 times 0? 0. So our y would be 0. So our rectangular coordinate, remember we have to write it as a coordinate, would be -2, 0. Let's do it again. So in the next one, our formulas are x is equal to r times cosine of theta, and y is equal to r times sine of theta. So this is our r, and this is our theta. So x is equal to √3 times cosine of pi over 6, and y is equal to √3 times sine of pi over 6. So I'm going to go to pi over 6 on my unit circle, which is here. For cosine of pi over 6, cosine tells us we look at the x or the y? The x. So my x value at pi over 6 is √3 over 2. So I have √3 times √3 over 2. What's √3 times √3? 3. Awesome. So x is equal to 3 over 2. Let's do the same to find our y. Y is equal to √3 times sine of pi over 6. So sine of pi over 6, do we look at the x or the y? We look at the y for sine. So our y at pi over 6 would be 1/2. So y is equal to √3 over 2. So I'm going to put this into my rectangular coordinate. We get 3 over 2, √3 over 2. This would be our answer. So in example 4a, it gives us rectangular points. We want to convert it to polar coordinates. first thing I want to do before I plug anything in, I want to figure out where this is on my plane. So if I were to just graph it a little bit, we just want to get an idea of which quadrant this falls into. We go to the right 2 and up 2, our point would be here. So we just want to make sure that whatever our polar coordinate is, it ends up in that same spot. So let's use our formulas. Let's find r first. We have r squared is equal to x squared plus y squared. And then tangent of theta is equal to y over x. So to find our r first, r squared equals 2 squared plus 2 squared. R squared equals 4 plus 4. R squared equals 8. Take the square root, so what does r equal? Awesome, 2 square root 2. Now, typically, when we would do this, we would say plus or minus 2 square root 2. We're going to stick with the positive. Remember, yesterday we talked about we have more than one polar coordinate for the same exact point. But I'm going to stick with the positive here. Just make sure that whatever value you pick, it's going to end up being a point in the first quadrant. So sticking to the first positive answer that we get when r is positive, we don't really have to worry about flipping it or anything. So our r is going to be square root 2 over 2. Let's find our theta. So we have tangent of theta is equal to 2 over 2. So tangent of theta equals 1. Remember, on our unit circle, it doesn't give us tangent. We got to do a little bit of work to find tangent. Well, just like our formula says, tangent is y over x. So we want to figure out where y over x is 1. And what will help us a little bit is we said that our point is in the first quadrant. So we want to look and see where in our first quadrant over here do we get tangent of theta equals 1. So it kind of, knowing where we graph it, gives us a hint of my coordinate's going to be somewhere over here. So which one of these theta values or radians here gives us a tangent of 1? Pi over 4, awesome. If we did square root 2 over 2 over square root 2 over 2 and keep change flip, this would equal 1. So pi over 4 would be our theta. So it's a little bit more challenging, I would say, when we're converting to polar coordinates, just because finding the tangent is going to be a little tiny bit harder, but it just takes practice, and it's thinking back to what we did when we dealt with our unit circle. So our coordinate here, remember, it always goes r comma theta. So 2 square root 2 comma pi over 4. Let's look at the next one. I'm going to convert the point to polar, so we're doing the same thing. So we have r squared equals x squared plus y squared, and the tangent of theta equals y over x. So let's find our r first. R squared equals -1 squared plus 0 squared. So r squared equals, this will be 1 plus 0. R squared equals 1, so r is what? 1. Perfect. I would always say stick with the positive r. Don't worry about the -1. Let's figure out where our point is here. That way it'll help us find our tangent. So I would go to the left to -1, stay at 0. So our point would be on the x-axis. This is super helpful because that way we kind of get an idea of where our theta is going to be. So here we have tangent of theta equals 0 over -1. Looking at our unit circle, I know that I'm going to stick to my x-axis here, so that really gives the answer away. But anywhere that we look to see where we have y is 0 and x is -1 would be at this point, so at pi. So what does theta equal? Pi. Perfect. Because 1, we knew where we graphed it was going to be on the x-axis, and 2, y over x would be 0 over -1 at this point. So our point would be 1, pi. Let's do C. Let's graph it to get an idea of where we're at. So let's graph it. We're going to go to the left to -1 and up 1. So our point's going to be in that second quadrant there. So this kind of gives us a little bit of a hint where our theta is going to be. Our formulas are r squared equals x squared plus y squared, and tangent of theta equals y over x. So r squared equals -1 squared plus 1 squared. R squared equals 1 plus 1. R squared is 2. So what is r? Square root 2. Now let's find our theta. So tangent of theta is equal to 1 over -1, which this simplifies to -1. So using our unit circle, looking at where our point is, we know that we're going to be somewhere in the second quadrant. So looking at my values in the second quadrant, which theta or which radian measure would give me -1 when I did y over x? Three pi over 4. If I did square root 2 over 2 over negative square root 2 over 2, this would equal -1. So our theta is going to be 3 pi over 4. So then our point, our coordinate for our point would be square root 2, 3 pi over 4. Now on the unit circle, there is more than one theta that would give us -1. We did this one where we had negative square root 2 over 2 over square root 2 over 2. That would also give us -1 for our theta, but we needed a theta that was going to be in the second quadrant. So that's why you have to graph it first, figure out where you're going to be. Not only does it help you find your theta, we know that we're going to be in the second quadrant, but it also gives you the correct theta. Any questions here? Let's do one more. All right, so we're going to convert the point to polar. Same thing. So r squared equals x squared plus y squared, and tangent of theta equals y over x. So r squared equals -1 squared plus square root 3 squared. R squared equals 1 plus, what is square root 3 squared? 3. Perfect. The square root and the squared cancel, so we just get 3. So r squared equals 4. Take the square root. What does r equal? 2. Awesome. Now let's find theta. Tangent of theta is equal to square root 3 over -1, or negative square root 3. Let's graph this to figure out which quadrant we're talking about. So I'm going to go to the left to -1 and up square root 3. So our point's going to be in the second quadrant. So I know that I'm looking at values over here where we can get negative square root 3. So if I did y over x, which radian measure would give me negative square root 3? 2 pi over 3. Perfect. Let's test it out just to make sure. We get square root 3 over 2 over -1/2. When we keep change flip, we would end up with multiplying by -2 over 1. So this would be negative square root 3. Perfect. So we said 2 pi over 3. So theta is equal to 2 pi over 3. Awesome. So our coordinate would be 2, 2 pi over 3.